So you can use mic, you can use chat, or you can also use the screen annotation to answer these questions. And after the session, you have to send a picture of the questions which we'll discuss today. A list of substances is shown. We have aluminum oxide, we have carbon dioxide, we have chlorine, diamond, ethanol, glucose, iron 3, limestone, nitrogen, and oxygen. Answer the questions, use the list. Each substance may be used once, more than once, or not at all. I'll send this to a group as well. So you can use this substance once, more than once, or even maybe you may not use for any of the part. The first one is state which substance, which of the substances is a reactant for photosynthesis. What is a reactant for photosynthesis here? What is a reactant? State which substances is a reactant for photosynthesis. So you have oxygen is a product of photosynthesis. Oxygen cannot be reactant. Carbon dioxide is a reactant. So you have to name this, but I'm writing in the formulas, but you will write the names. So carbon dioxide should be there. Is the main constituent of the bauxite. What is the main constituent of bauxite? Aluminium oxide. Because the ore of aluminium oxide, so that's right. Are the two products of fermentation? Fermentation give these two products. And what is the second product of fermentation? No, in a fermentation, yes, that's right. Ethanol and carbon dioxide. Because fermentation of a glucose will give ethanol, and the second product is a carbon dioxide. Then we have in part D is a use as a fuel. Which substance can be used as a fuel? Fuel. Good. So substance which can be used as a fuel, that is ethanol. Hydrogen is not given as an option. So in this list, you have to use from the list. So which substance is used as a fuel? So ethanol is used as a fuel. Hydrogen, if hydrogen was there in the list, yes, then hydrogen is acceptable. Hydrogen can be used as a fuel, but because it's not in the list, so we cannot write that. Is a greenhouse, the next is a gas used to convert iron into steel. Like we change the composition of iron from the blast furnace, we change the composition, which gas we use to do that. Like iron, which is from the blast furnace, it contain impurity of the carbon. How we can remove or how we can change the amount of the carbon? Which reagent is used here? Which chemical? Oxygen. Oxygen, it's not a limestone, it's oxygen. Because oxygen react with carbon, it gives carbon dioxide. So we can change the composition of a carbon in the sample. That's why the gas which is used to convert iron into steel, that is oxygen. The greenhouse gas, which of them is a greenhouse gas? Which gas is a greenhouse? Carbon dioxide. So carbon dioxide gas is a CO2 or a carbon dioxide. But in exam, you are here supposed to write the names. So don't write the formulas, write their names. The carbon dioxide is a gas which is approximately 78% of a clean dry air. Which gas is 78%? So which is nitrogen, 78% of a clean dry air. And the last one is a form of a carbon. Which is a form of a carbon? Diamond. So the last one is a diamond. So here, the one which is a greenhouse gas, that is carbon dioxide. Then we have 78% of that is a nitrogen, and it's a form of a carbon, that is diamond. Moving on to the next page. Answer for E. Used to convert the iron into steel. So which gas is used to convert the iron into steel? When we are converting iron into steel, we are changing the percentage of a carbon. How we change the percentage of the carbon? So for that purpose, we use a basic oxygen furnace. In a basic oxygen furnace, we have the molten iron from the blast furnace, which contain carbon impurities, as it was not originally there, but in the blast furnace, a carbon is added. So how this carbon can be removed from the molten iron? By blowing the oxygen. So carbon react with oxygen, give carbon dioxide. So we need oxygen here. We need oxygen to remove the carbon. Is it clear? The next question, this question is about the compounds of sulfur. Sulfuric acid is manufactured using a contact process. The manufacture involves 4 stages. Molten sulfur is burned in air to produce sulfur dioxide. Sulfur dioxide reacted with oxygen to form sulfur trioxide. Sulfur trioxide combined with a concentrated sulfuric acid to form oleum. And oleum reacted with concentrated sulfuric acid. Oleum react to form. So oleum actually dissolve in water. Write a chemical equation for the first stage of a reaction. So we have a molten sulfur burns in air. So to produce sulfur dioxide. So sulfur burns in air, sulfur react with oxygen to give sulfur dioxide. State the essential conditions that are necessary for stage 2 and write an equation. So what are the essential conditions? Because the sulfur dioxide react with oxygen to form sulfur trioxide. This is a reversible reaction. 2SO2 plus O2 gives 2SO3. So the reaction is reversible and it is exothermic reaction, the forward reaction. So what temperature we maintain for this? What is the temperature used for this reaction? 450. What is the catalyst used for this reaction? Vanadium pentoxide, so V2O5. And what is the pressure we maintain? High pressure is there, 2 to 3 atm. That is the pressure we maintain for this reaction. Then write a chemical equation for reaction occur for stage 3. Stage 3 sulfur trioxide combined with sulfuric acid. So sulfur trioxide we have combined with sulfuric acid H2SO4. What it will result? It will result in a formation of H2, S2 and O7, oleum. Name the substance that react with oleum in stage 4. Stage 4, oleum is diluted with water. But this part is not there anymore. Like you don't have to learn the manufacture of sulfuric acid by a contact process. The whole method is not there. So this part is removed from the syllabus. Only you have to learn the reaction condition for the Haber's and the contact process. Hydrogen sulfide has a formula of H2S. Complete a dot and cross diagram. You can annotate on the screen, use a dot and cross diagram to complete this. Dot for one and cross for the other. You can annotate on the screen, drawing the molecule of a hydrogen sulfide. So hydrogen share 1, sulfur share 1, hydrogen share 1, sulfur share 1. Then sulfur belongs to group 6. So how many unshared electron will be there for sulfur? So element belongs to group 6. How many unshared electrons? So there should be 4 unshared electrons. That's right. Because 2 of them are used in a sharing. So 2 unshared electrons, 4 unshared electrons will be there for group 6 elements. Next is balance the chemical equation. Use the screen annotation, balance this equation. For balancing, you can start for normal equation, start with oxygen followed by hydrogen and then any other element. For combustion equation, carbon, hydrogen, and oxygen. That should be the order. Combustion. But normal equation, start balancing oxygen, try to balance oxygen first, then hydrogen. So how many oxygen are there? We have 2, so we put 2. That's right. So oxygen is balanced. Hydrogen, 4 are there, we put 2. Hydrogen is balanced. What about sulfur? It should be 2 or 3. Because this 2, yeah. This 2 here and 1 here, so makes 3. So we should have 3 sulfur. So the equation will be balanced. Clear about this? Balancing part. In this question, use the screen annotation to answer the questions. Annotate on the screen directly. Give the name of the process that is used to produce ammonia from nitrogen. What we call when nitrogen, hydrogen react to give ammonia. What we call this process? You can annotate on the screen. Haber's process, good. Which method we can use to separate the nitrogen from a liquid air? So that is a fractional distillation. That's right. You can use any part of the screen. It's fine. Anywhere you can use. It's fine. To produce a bromine from a molten lead to bromide. Like we have lead to bromide and we want to produce a bromine. Which method we use? Electrolysis, right? So we can use electrolysis. Good. It is used to separate undissolved solid from aqueous solution. Like the substance which does not dissolve, we can separate this by this method. What we call filtration. Good. To produce amino acids from protein, that is polymerization, opposite, that is called hydrolysis. You will learn this later in organic chemistry. The hydrolysis of the protein will give the amino acid. Used to separate the mixture of amino acid. How we can separate them? Today we did that. So that is chromatography. So chromatography is a technique which is used to separate the mixture. So first one, to produce ammonia from nitrogen and hydrogen, Haber. To separate the nitrogen from a liquid air, fractional distillation, we use electrolysis of a molten electrolyte, and then we use filtration to separate the undissolved substance. We use hydrolysis of a protein to give amino acids, and we use a chromatography to separate or identify the mixture in amino acids. So we did the first 4 pages. So now every session we'll do some classified paper from different topics. Send the picture of the first 4 pages.